Hello and welcome back to you in the new lesson. This is Lakshmikant Tiwari. In the previous tutorial, we have created a CC3200 DSP library. In this project, we are going to use those library to create a new project. Okay, so we are going to create a CMSIS variance project. So the first click on the project and the new project. Just give the name here CC3200 underscore variance, and this is the CMSIS project. Okay, select the CC3200 if not selected, and also select the Stellaris in circuit debug interface. Then click on the empty project, and in the advanced setting, please click on the executable if it is on the static library. In the previous project, we have selected the static library. Because of that, we are creating a static library. But here we are creating a project, so please select a executable. Okay, and then click on the empty project and then finish. Then right click on the project and then add files, and then navigate to the C and then CMSIS and then DSP library, then example, and then please select this variance example and then into the ARM and select all C files from here. So this is the C file only. So ARM variance example F32. Then click on the OK and then copy this file. You can also link to the file, you can copy to the file. Okay, I am going to copy this file and then copy this file. Fine, and then set the some properties of the project. So the click on the general and verify everything, then ARM processor, then click on the VFP and then into the optimization, select the second level of the optimization. This is the global optimization, and into the include option, please include the CMSIS library file. Okay, so this is the CMSIS include. Click on the OK and then advanced option, click on the language support, and then here enable support for GCC extension, and then into the predefined symbol select those two symbols which we have selected into the our previous tutorial. Copy this, then paste it here, and then select next one. The second one is the view present, and then copy it and then paste it here. Fine, and into the diagnostic option reselect it, and then into the runtime model make sure, and to the advanced no problem, the library function to the assembler use the unified language. Okay, and into the ARM linker click on the expander button. Into the basic option please select the heap size as a 512. Okay, and then the file search path select our library file. So the go to into the file system and then documents where we have created our DSP library. So this is our DSP library here, CC320 underscore DSP. Okay, and then click on the open and then click on the OK. It has been fine. Now let's just build this project and let's wait. Now you can see everything is fine. The optimization is the 3 level. We have got no error. So our program has been successfully built here. Double click on this. Now you can see this is the our ARM variance example F32C. Okay. So this is we are including math.h. Here ARM math.h, and this is the block size for the 32. And this is the data, the test data for which we will create the variance and the mean value. And for the variance and the mean value, we have created these float variables for the mean and the variance. Okay, so at the first place we are calling the ARM fill. Right? Okay, it will fill the variables with the 1, and then ARM dot product, we are doing the dot products, and then finally we are doing the multiplication of the vectors. Now we are filling the variables with the mean value, and here we are subtracting and then copy and then again doing the dot product and then again doing the final variance multiplication. Okay, and then we are getting here the variance in this variable. Okay, this is the total algorithm explained here, how these algorithms are working. You can read this algorithm and then you can easily understand this. In the next tutorial we will solve this variance on the CC3200 Launchpad Cortex M processor. And thank you so much for watching, and stay tuned for the next tutorial.